Week 1 homework. So question number 1, how is sample related to a population? First of all, sample is a subset of population. And what population is and what sample is. Let's assume you want to find out what is the average age of population in United States. You are not going to go and knock door to door, right? Somebody will call 911 for you. So therefore, you are choosing from each region, let's say west, east, south, and north. You are choosing some states. And then states are choosing some cities and then counties, and they do sampling, subset. Okay, once they do their sampling, their survey, let's say questioning, finding the average age, they put it together and let's assume they report to DC and north and south and east and west. Okay, so and based on the result they get from 4 regions, they decide, they apply the result to entire population of United States. Now, so sample is a subset of population. Let me mark this down. But can we insist that that's going to be 100% correct? Never. Statistics never gives you 100% correct answer. Therefore, always and always, it's going to be error. There is going to be error, will always leave some error. And it's very important part in statistics, because if we can reduce the error, so that's mean the truthful part, the confidence is going to increase. Yes. So, but to answer the question, sample is a subset of population. Final check. Bingo. Next question. Why is a sample used more often than a population? Well, because usually it's impossible to research the entire population. Let's say you want to research the behavior of dolphins. How on the earth you can catch all dolphins in the world, or birds, or behavior of children? So because it's impossible, it's usually impossible, therefore, to count entire population, therefore we are using sample. Okay. Next one. 2 main branches in statistics are descriptive statistics and inferential statistics. Descriptive statistics is collecting data, analyzing data, and then, organizing first. After they collect the data, they organize. What do I mean by organizing? They keep the data they need, and the data they don't need, that they leave it out. And then they analyze. So once they do analysis, the result they pass to inferential statistics that draw the conclusion from analysis. So that's what it is. Inferential statistics draw conclusion from analysis, and descriptive collecting, the organizing data and analyzing data. Next, question number 4. The number of pets for 20 households in a town with 300 households. So when it says 20 households in the town, it doesn't mean entire town. They just choose 20 households, right? That means it's a sample, it's a subset. So it's going to be which one? We have 2 cases of sample, B and C. So subset because a collection of number of pets in all households in the town, but there are other towns. No. What do you mean there are other towns? We are talking about town, and town is our population. And sample, the D, let's read D. Sample because a collection of numbers of pets for 20 houses is a subset of all households in the town. Bingo. Should be this one. Nice work. Question number 5. A survey of 500 spectators from a stadium with 42,000 spectators. Okay, well, let's see. Survey of 500 from stadium. Okay, so they are doing survey of 500 out of 42,000. That means 500 is a sample, 42,000 it's a population, right? So it's going to be sample. We have two versions here, A and C. So I think it's a C sample because the collection of 500 spectators survey is a subset of all spectators in the stadium. C. Next one, number 6. The age of each member of the House of Representatives. Bingo, here we are dealing with population. We have so many members of House Representatives, right? So it's going to be population, which is C or D. Population because it is a collection of ages of all members in the House of Representatives. I say this one. And D, what was D? Population because it is subset. No, that's a nonsense. So, okay. Number 7. The height of each student in the classroom. Each student, meaning the classroom is our population, and all students in the classroom are representing population, right? And since we are doing each student, that means all students. It's a population. But which one population? Let me see. Population because it is subset of all students. No, that's baloney. C, population because it is a collection of height for all students in the classroom. This one. Question number 8. Determine whether the underlying numerical value is a parameter or statistic. So we need to find out this 40.5% is parameter or statistics. Okay, a survey of 42 out of hundreds in a dining hall showed that 40.5% enjoyed the meal. So 40.5 out of total amount, right? Out to the 40.5% of 100. Yes, that means it's a portion, meaning it's a subset, which means it's going to be statistics. So where do we have statistics here? D, F, G, and H. Let's see which one is going to be the answer. So D, let's see. D, statistics because the data set of 42 people in a dining hall is a population. That is baloney because it's not a population, it's 100 is a population, right? Moving to next one. Statistics because the data set of all people in the dining hall is a population. Yes, all people, that is true, is a population, but we are interested not in all people, but 40.5%. Correct? Okay. Because statistics because the data set of all people in the dining room hall is a sample. That is not true. All people is a population, and it looks like it's going to be the last one. Statistic because the data set of 42 people in a dining hall is a sample. Bingo. These 42 people makes 40.5% out of 100. All right. Let's check. Bingo. Question number 9. So we have the fact that they studied 4,898 students at a college, and it was found that 40% out of these 4,898 students own a vehicle. Okay, 40% of the population. So Parameter because the value is a numerical measurement describing a characteristic of population. Okay, this 40% describing this population. So it's going to be this one. It's 40% of this 4,898. It's a parameter of this because we are dealing with 4,898 and some portion of this population owns car. So it's going to be parameter that is describing population. Excellent. Question number 10. Let's see what we have. Suppose a survey of 920 car buyers found that more than 31% bought leather seats. Okay, which part of the survey represents a descriptive branch of statistics? Make an inference based on result of the survey. So let me see. What is going to be? The fact that 31% bought the leather seats. Okay, that's a descriptive. It's just describing the fact, right? Fantastic. Okay, next question. Choose the best inference. So meaning what conclusion we can draw. So most car buyers do not buy leather seat. It's because if it's 31%, then the rest do not buy, right? 920 car buyers were surveyed. That will be, I'm sorry, that was surveyed. That will be discrete. It's just describing the fact. C, there is no association between car buyers and buying leather seats. This is also not the inference because it's not drawing conclusion. And 31% of car buyers in the sample bought leather seat. This is also a fact. This is not an interpretation what that means. 31% bought the leather. So I say this one. So just because only 31% bought the leather seat, we can say that most car buyers do not buy leather seat. That's the explanation we can give. Fantastic. Moving to question number 11. Okay, determine whether variable is qualitative or quantitative. Explain the reasoning. All right. Favorite film. Well, the variable is going to be the film itself. It's a unique, right? Okay, so I would say the variable is quantitative because a favorite film is found by measuring or counting. No, described an attribute. I would say this one. So they are similar. Hold on. Either B or C. Let's read. Variable quantitative because a favorite film describes an attribute or characteristic. And C, the variable is qualitative. Okay, because film described attribute or characteristic. Film, I would say per se. That film is, every film is unique, right? So it's a quality, not quantity. And it's described, favorite is describing the attribute. Very good. Question number 12. In statistics, you have to read carefully the questions. Okay, determine whether variable is qualitative or quantitative. Explain reasoning. Wait time at bank. So wait time, it's going to be quantitative time. You can count, right? 1 hour, 2 hours. Because the wait times are numerical measurements, right? Fantastic. Moving on fantastically. In a survey of 1,380 adults in the country, 56% said the country's leader should release all medical information that might affect their ability to serve. So the study is, well, it's not experiment. You don't put on experiment. You are observing the result, right, of document medical condition, because it is does not apply the treatment. This has nothing to do with treatment, right? Very good. Moving to question number 14. The study, the effect of social media on teenagers' brain, researchers showed a few dozen of teenagers photographs that had varying numbers of likes while scanning a reaction in their brain. Okay, this is interesting. So this study is going to be, because it was study, brain researchers showed a dozen, so it was experiment, right? Because of varying number likes of this. So this is experiment because they are testing teenager's brain. Okay, it is applies the treatment of the teenagers. Excellent. Moving to number 15. So identify the sampling technique. Next, we are going to identify sampling technique. Before I move further, I want to explain that there are several techniques. One is cluster, stratified, okay, systematic, and random. You can write down cluster, stratified, systematic, and random. Random when, let's say, you generate number and give this number to, let's say, student, and then they say whoever has number 5, 15, 25, step out and you are going to evaluate the dean. Okay, this is random. Cluster, when you break down, let's say, people into group, be it by gender, be it by age, be it by profession, be it by income, whatever. And then the entire group is participating in the research. That is going to be cluster. Stratify, when you, again, breaking down into groups, just like in the case of cluster, but instead of the whole sector, you are taking people from there, or the elements from there you are taking randomly. That is a stratify. So in this case, we are going to choose between cluster or stratify sampling. Okay, after a flood, disaster area is divided into 250 equal grids. Those are sectors, right? 250 grids. Let's see. So every grid is going to be taken, or just a portion of it. 50 of the grids are selected, and every occupies, so only 50 selected. So that's it. I don't need to read further. It tells me it's a stratified. Okay? So stratified, sorry, 50 of grids are selected and every occupied household in the grid. Okay, although they took 50 grids, every single element, or in this case household in that grid, that is going to be cluster. In the grid is interviewed to help focus focus relief efforts on what residents require the most. Okay, so let me see. It's gonna be cluster, but which one? Either A or D. Let's start with D. So cluster sample is used since the disaster area is divided into grids and random sample is taken. No, from cluster, when you have cluster, you don't choose randomly. Okay, the entire cluster has to participate. Remember here, that's why I stopped. Every occupied household in these clusters. A cluster sampling is used since a disaster area is divided into grids, and some of those grids are selected, and everyone in those grids is interviewed. That is the case cluster. Well done. And next one, a certain grids. What potential source of bias is present, if any? Okay. Certain grids may have been much more severely damaged than others. That's true. The grids that are selected may not be representative in terms of damage. Okay, this is one. And then another, certain grids may have been much more severe damage. Also this one. Okay. The D, answer D, it's eliminated because there are no potential sources of bias. You never know, right? And the sample only consists of grids that are easy to get. This is also not the case. Nice work. Question number 16. Okay. So what type of sampling do we have is used? Every 10th person entering cafeteria, every 10th person, that is systematic. Let's say I am inspector and I'm going to Publix to inspect a gallon of milk, the quality of milk. So I'm going to Publix and asking shop assistant to give me every 10th gallon. So systematic. They can start not from the beginning, but from on the window where gallons are lined up. Anywhere from the line to take and start, let's say if a 10th one, then every 10th gallon it's gonna deliver to me for checking. So it's gonna be systematic. Fantastic. And what potential source of bias can be? So let's see. People who don't enter the cafeteria are not sample. This is not biased. If there is a regular pattern to the people entering cafeteria, the sample may not be representative. This has nothing to do with being biased. The wording of the question may direct respondents towards a particular meal. This can be the source of bias, the wording, right? You can play there with these words, interpret this way or interpret that way. And the other one, there are no potential source of bias. This is also not the case. Let me see. I think this one, let me read again. If there is a regular pattern to the people entering the cafeteria, the sample may not be representative. This one can be biased. That's right. Because people entering cafeteria, the sample may not be representative. Yes, this case can be biased. Let's check. Bingo. Number 17. Okay. Identify the sampling techniques. So what do we have? Simple, convenience, cluster stratified. We learned already cluster stratified and systematic, but we are not familiar with simple and convenience. Convenience, it's when you are sampling at your convenience. For example, I go stand in front of the store and survey anybody who will walk to the store to my convenience. Yes? And sample random, we already know. I explained to you when you give out the numbers to people and then let's say generate random numbers and whoever holds the number will step out for sampling. So let's see what we have. Lettuce is planted on a 47-acre field. The field is divided into 1-acre subplot. A sample is taken from each subplot to estimate the harvest. So every subplot, there are so many subplots, and sample taken from each subplot sample, meaning portion of it, that's going to be stratified. Break down into sectors, in this case is subplot, but they take portion of it, sample, right? Subset. So this is going to be stratified. We have only one case of stratified, and that is going to be the case. And what potential sources of bias are present, if any? Okay. So certain subplots may have more or fewer letters planned than others. Samples from this subplot may bias the overall sample. This is going to be our possible bias.